Good morning, students. In continuation with the last class, today I am going to solve few more previous question paper problems. Till now, in gear trains, especially on Epicyclic Gear Train, we have solved the 10 problems. In addition to that, today I am going to solve few more numericals on Epicyclic Gear Train which have come in the previous question papers. That is, this problem number 11 appeared in January 2015. I'll read the statement. An epicyclic gear train as shown in figure. Internal gear A is keyed to the driving shaft and has 30 teeth. Compound wheel C and D of 20 and 22 teeth respectively are free to rotate on the pin fixed to the RP, which is rigidly connected to the driven shaft. The internal gear B, which has 32 teeth, is fixed. If the driving shaft runs at 60 rpm clockwise, determine the speed of the driven shaft and what is the direction of rotation of driven shaft with respect to the driving shaft. So this is the figure which is given. Now, according to the figure, if I refer the given figure, that can be redrawn in our own way so that we can solve the problem. Now, in the statement, what is saying, internal gear A is keyed to the driving shaft. So there are two shafts, one is driving shaft, another one is driven shaft. So the internal gear A having 30 teeth is keyed to the driving shaft, which you can see in the figure. And there is one compound wheel, means two wheels which are concentric and coaxial with each other. Compound wheel CD are free to rotate on the pin fixed to the RP, which is rigidly connected to the driven shaft. So on the driven side, you can see the compound wheel C and D having 20 and 22 teeth are free to rotate on the pin fixed to the RP, which is rigidly connected to the driven shaft. And there is one more gear, internal gear, that is internal gear B, which is having 32 teeth, but it is fixed. Now with this, here first how to draw this figure. There are two internal gears. One is gear A having 30 teeth, another one is gear B having 32 teeth. So two internal gears, gear A 30 teeth and gear B 32 teeth. Both are internal. So just with some convenient radius, you draw two concentric circles. Outside one is B, inside one is A, but both are having internal teeth. And one more wheel, that is a compound wheel. So CD having 20 and 22 teeth respectively. So compound wheel C, if you look at in the figure, C is gearing with A and B is gearing with D. So therefore, I will introduce on any one side, either top or bottom or left or right, anywhere you can draw. So two small circles which represents the compound wheel CD, so that the C should gears with B and C should gears with A and gear D should gears with mesh with B. That is what in the figure you can see. C with A and D with B. Like that, two wheels which are said to be compound wheel CD. C is meshing with internal gear A and D is the wheel D is meshing with the internal gear B. Next, these two are rotating. Freely rotating on the pin fixed to the RP. So now draw the one arm. one end you connect it to the compound wheel, another end you connect it to the driven shaft, because he is saying so arm P which is rigidly connected to the driven shaft. So like that you can draw the figure. Now what he has given in addition to that, so here number of T's on the internal gear, TA is 30, wheel C is having 20 teeth, that is TC is 20, wheel D is having 22 teeth, so TD is equal to 22, and wheel B, one more internal gear, that is having teeth 32. So number of teeth on wheel B is equal to 32. Next, if the driving shaft runs at 60 rpm clockwise, here gear A is connected to the driving shaft and arm P is connected to the driven shaft. So therefore, if the driving shaft runs at 60 rpm clockwise, so speed of driving shaft is equal to 60 rpm in the bracket clockwise. But for this driving shaft, which gear is being keyed? So gear A is keyed to the driving shaft. Therefore, speed of the driving shaft is nothing but the speed of the gear A, which is equal to 60 rpm, and I have mentioned negative because clockwise. According to our sign convention, clockwise is negative, anti-clockwise is positive. Therefore, NA is equal to minus 60 rpm. Then what I should find? Determine the speed of the driven shaft. So speed of the driven shaft or driven shaft on which the arm is mounted. Arm P is keyed to the driven shaft. Therefore, speed of the driven shaft is nothing but I should find the speed of the arm. And also direction of rotation of driven shaft, means in what direction it rotates, either it is clockwise or anti-clockwise. So I should find the speed of the driven shaft and its direction. Then nothing but speed of the arm and its direction. So to find this, so let us first of all get ready with the tabular method by completing the table. So in the table, as you all know that the first column is step number, second column is conditions of motion, and third column is revolutions of elements. So under revolutions of elements, now in the given gear train, totally there are 3 elements excluding the arm P. So one is arm P, second one is internal gear A, third one is internal gear B, and the fourth one is compound wheel CD. But out of which, in what priority or in what order these elements are to be listed in the table should be understood. Here anyhow the gear train is having a arm, so by default I will assume that I am going to fix the arm P. So after fixing the arm P, so then I will give a rotation to the gear A. So therefore, first one is under revolutions of element. First is arm P, which I am going to fix, and next I am going to give the rotation for the gear A. Therefore, second is gear A. So when the gear A given revolutions, the compound wheel is going to rotate. So therefore, because one of the wheel in a compound wheel CD is meshing with A, therefore as and when I rotate A, compound wheel CD will rotate. So therefore next is gear CD, and once the compound wheel rotates, the internal gear B will also starts rotating. Therefore finally gear B. Like that in the order. In what order I should enter, that depends upon first which element I am going to fix. Secondly, for which element I am going to give the rotation. Here I am fixing the arm P. Therefore that is first. Second is gear A, because I am going to rotate the gear A. And once the gear A is rotated, next compound wheel rotates. Therefore next is compound wheel CD. So once the compound wheel rotates, gear B starts rotating. Therefore finally gear B. Like that under revolutions of elements, arm P, gear A, gear CD, gear B. Now first step. So arm P should be fixed, because that is what my assumption. arm P should be fixed and gear A should be given +1 revolution. Plus means anti-clockwise. So you rotate the gear A in anti-clockwise direction by 1 revolution. So arm P fixed, gear A given +1 revolution. So now enter the values. Under arm P, 0 I am going to enter because arm P is fixed, and gear A I wrote it inside the cell as +1 because gear A have rotated in anti-clockwise by 1 revolution, therefore +1. Once the gear A is rotated, so gear A is in mesh with the compound wheel CD, especially the gear C is in mesh with the gear A. Therefore, the speed of the gear CD is equal to TA by TC. TA by TC will give you the speed, because how to find the velocity ratio in between the two wheels? So speed of the driven by speed of the driver is equal to ratio of reciprocal of their teeth. Here A is driving the C as it is in meshing with A. So gear A I am rotating, therefore gear A is a driving member, gear C is a driven member. So the speed of driven by speed of driver, that is NC by NA, is equal to reciprocal of their T's, that is TA by TC. Therefore speed of the compound wheel is TA by TC, and I just mentioned it as plus because gear A is in mesh with C. So in what direction? Because gear A is having internal teeth. So therefore in what direction I am rotating the gear A, in the same direction compound wheel CD will also rotate, because gear C is in mesh with internal teeth of gear A. Therefore, in the same direction gear CD will also rotate, means anti-clockwise, therefore plus. Next, once the gear CD found, next how to find the gear B? So once the gear C rotates in clockwise, in anti-clockwise, gear D will also rotate in the same direction with the same speed. As and when the D rotates in clockwise, the gear B will also rotate in the same direction, because gear B is also having the internal teeth which are in mesh with the gear D. So now the speed of the gear B is equal to TA by TC into TD by TB, because directly, so I should find the gear B with respect to A, and CD is a compound wheel, therefore TA by TC into TD by TB. So this product will give you the speed of gear B, and gear B is also rotating in anti-clockwise, therefore plus. Like that, the first row should be completed very carefully. Next, go to the second step. Once again, arm P is fixed, but gear A, instead of +1 revolution, now let us rotate the gear A by +X revolution. Nothing but what I should do, students? I should multiply the first row values with X. So 0 into X is 0, 1 into X is X, TA by TC into X is X TA by TC, and TA TD by TC TB into X is nothing but X into TA TD by TC TB. So all first row values should be multiplied with X blindly. Then third step, add plus Y revolutions to all elements. Just blindly go on, enter +Y for all the elements. Now in the fourth step, find the total motion. So total motion is always sum of the second row and third row value of each element. Arm P, what is its second cell value in that column? 0. So third is I am adding Y. So 0 plus Y is Y. X plus Y. I should add second and third of each element. So X plus Y is X plus Y. Y plus X into TA by TC. Y plus X into TA TD by TC TB. So like that, the total motion of all the elements should be calculated by using a tabular method. Now, only after completing the table, one should remember the last row, because y is nothing but speed of arm P. X plus y is the speed of gear A. Y plus x into TA by TC is speed of gear CD. So y plus x into TA TD by TC TB is the speed of the gear B. So only you from the table means always you should refer by default the last row, that is fourth row values should be taken. Now, to find what is to be calculated, what is to be determined, I should determine, here we have to determine the speed of the driven shaft. So driven shaft, for the driven shaft, which element of the gear train is keyed or mounted? So arm P is mounted on the driven shaft. Therefore, speed of the driven shaft is nothing but speed of the arm. To find this speed of the arm, so right, first, so if you read the statement of the problem, internal gear B, which has 32 teeth, is fixed. Therefore, it is given that gear B is fixed, nothing but NB is equal to 0. But from the table, what is the speed of gear B? That is from the last row, y plus x into TA TD by TC TB. That is equal to 0 because gear B, he himself in the statement told that it is fixed. So now y plus x, where y and x values are unknown, into TA, TD, TC, TB, number of T's on all four wheels are known, substitute, that is equal to 0. Then y plus, if I simplify, y plus 1.03125 into x is equal to 0. You call it that as equation number 1. Right. Similarly, he has given that speed of the driving shaft is equal to minus 60 rpm. So NA, already we have listed out NA, speed of the gear A, or it is the speed of the driving shaft, which is equal to minus 60 rpm. But from the table, once again I can write speed of the gear A is equal to x plus y. Therefore, x plus y is equal to minus 60. You call it that as equation number 2. Right. Now solve the equations 1 and 2. X plus y is equal to minus 60 and y plus 1.03125, x is equal to 0. If I subtract both the equations, y gets cancelled, then it will be minus 0.03125x is equal to minus 60. So if I simplify, x will be equal to 1920. Now substitute this x value in equation 2. Then x plus y is equal to minus 60. Just now I got the x value, that is 1920 plus y is equal to minus 60. Thereby y value will be minus 1980. Like that, with the given conditions, gear B is fixed. I am going to get one equation. Gear A is equal to minus 60. With that, one more equation. Solve these two equations and find out, first of all, what are the values of x and y. Once the x and y values are known, now let us find the speed of the driven shaft. So, as I said already, speed of the driven shaft is nothing but the speed of the arm, as arm is keyed to the driven shaft. So, now from the table, so what is the speed of the arm? That is y. Therefore, y is equal to, directly, I need not to find, already I know. So y is equal to minus 1980 rpm. So therefore, you write down speed of the arm or speed of the driven shaft is equal to, simply without sign, 1980 rpm. But it is 90 actually. Therefore, in the bracket you have to write clockwise. Like that, you can find the speed of the driven shaft or the driving shaft. Next, one more, that is problem number 12. It is appeared in June-July 2017. Now, an epicyclic gear train has a fixed annular wheel C. An epicyclic gear train has a fixed annular wheel C, concentric with sun wheel A. a planet will be gears with A and C and can rotate freely on a pin carried by an arm which rotates about an axis coaxial with that of A and C. If T1 and T2 are the numbers of teeth on A and C respectively, show that the ratio of the speeds of D to A is T1 by T1 plus T2. Now this is the figure which is given. So or with the statement one can draw the diagram also. What he is saying, there are totally 4 elements. One is fixed annular wheel C. Second one is sun wheel A. Third one is planet wheel B. And fourth one is arm. Now first you draw a circle showing the annular wheel C, and that is fixed. What he is saying, it is fixed. So annular wheel means the wheel is having internal teeth, and this is concentric with sun wheel A. So with the same center draw one more circle that you name it as sun gear A. So like that, epicyclic gear train has a fixed annular wheel C concentric with sun wheel A. So you have to draw the 2 circles which are concentric with each other, means with the same center you must draw. That is what I have drawn. One is outer circle, another one is inner circle. But same center because both are concentric. Next, what is saying, a planet will be gears with A and C. So in between sun gear and annular gear, I should draw one more circle which is representing a planet wheel B, because planet wheel B should mesh with A and C. So and can rotate freely on a pin carried by an arm. So therefore now, so I should draw the arm whose one end is to be connected to the planet wheel, because it is rotating, planet wheel is rotating freely on a pin carried by an arm which rotates about an axis coaxial with that of A and C. So this is an arm. Now if T1 and T2 are the numbers of the teeth on A and C, then show that ratio of the speeds of D to A is T1 by T1 plus T2. Now list out the given things. Here number of teeth on gear A, that is TA, is equal to T1, and the number of teeth on gear C, that is TC, is equal to T2. And we'll see in the first line of the statement itself, it is fixed annular wheel. Therefore, so wheel C is fixed. Therefore, NC is equal to 0. Then what I should find? I should find the ratio of speed of D to A, that is ND by NA, is equal to T1 by T1 plus T2. So to find this, as usual, by default, let us draw the table. So first step, then second is conditions of motion, third one is revolutions of elements. Now as here there is an arm, so let us fix the arm D and give the rotation for the sun gear A. So therefore gear A. Gear A is in mesh with the pinion wheel B, therefore next is gear B. And pinion wheel B is in mesh with internally with the annular wheel, therefore gear C. So like that, in the order I should enter the elements under revolutions of elements. First arm D, which I am going to fix. Second, I am going to give the revolution for the sun gear A, therefore gear A is second, and next gear comes into the table is gear B, because A is directly in mesh with B. So after gear B then comes gear C, because gear B is directly in mesh with the gear C. Like that, first draw the table with all the elements in the order. Next step number 1, arm D is fixed. So arm D, I should assume that it is fixed. So arm D is fixed and rotate the gear A in anti-clockwise direction by 1 revolution. Therefore, I am going to write in the conditions of motion, arm D is fixed and gear A is given plus 1 revolution, because by fixing the arm D, I am rotating the gear A in anti-clockwise, therefore plus. By how many revolutions? 1 revolution, therefore plus 1 revolution. Now enter the values of the elements. Arm D is 0 because it is fixed, and gear A is rotated 1 revolution, therefore plus 1. And once the gear A rotates in anti-clockwise direction, gear B rotates in opposite direction, because A and B are in mesh with each other externally. So therefore speed of the gear B will be in clockwise, therefore minus. And what is its speed? That is minus TA by TB. So TA by TB is equal to the speed of the gear B. Next, gear B rotates in clockwise, and once it rotates in clockwise, gear A starts rotating in the same direction, because gear B is in mesh with gear A internally. So therefore gear C will also rotate in the clockwise direction, therefore again minus. But how to find? TA by TB, previous one, into TB by TC. Now TB gets cancelled, then minus TA by TC is the speed of the gear C. That completes the first row. Second row, arm D is fixed again, but gear A, instead of plus 1 revolution, now it should be rotated in anti-clockwise by X revolutions. Nothing but what I should do, students? I should multiply all the first row values with X plus X. So 0 into X is 0, 1 into X is X, minus X into TA by TB. Just simply multiply with X all the first row values, minus X into TA by TC. Then go to the third step, add plus Y revolutions to all elements. Simply in all the elements, for all the elements, go on right or go on add plus Y plus Y plus Y plus Y. Next, find the total motion in the fourth step. So how to calculate the total motion? I should add second and third. 0 plus Y is Y, X plus Y is X plus Y, Y minus X into TA by TB, Y minus X into TA by TC. Like that, second and third one of that element should be added. Second and third values of that element only. Like that, table should be completed. Now, as we listed out in the given things, NC is equal to 0. Why NC is equal to 0? Wheel C is fixed. So speed of the wheel C, that is NC, is equal to 0. But from the table, what is the value of NC? That I can get it from the last row, gear C. So NC is equal to Y minus X into TA by TC. That is equal to 0, as he himself is telling that it is fixed. Therefore, Y minus X into TA by TC is equal to 0. But what is TA? It is the number of T's on the gear A, which is given as T1. TC, that is the number of T's on the wheel C, that is given as T2. So therefore, Y minus T1 by T2 is equal to 0, or Y is equal to X into T1 by T2. Next, what I should find? I should find the ratio of ND by NA. So ratio of the speed of the gear A to the gear D is, that is ND by NA is equal to, what is ND? Speed of the gear D. So from the table, what is the speed of the D? That is nothing but RD. So Y. So Y, I am writing divided by NA. NA is what? Speed of the gear A. That is from the last row, it is X plus Y. Therefore, Y by X plus Y. Then what is Y? Just now we calculated. It is X into T1 by T2 by X as it is plus Y. Now I am substituting the known values. Only I know the value of Y. That is equal to X into T1 by T2. So substitute Y value. Then take in the denominator X outside, or as it is a common. Then I will be left with 1 plus T1 by T2. Next I can cancel X and X. then T1 by T2 by 1 plus T1 by T2. So now in the denominator take LCM, T2 is the LCM, then it will be T2 into 1 is T2 plus T1 by T2. So therefore now T1 by T2 into bring this denominator term above, then it will be T2 by T1 plus T2. Now T2 T2 gets cancelled, then T1 by T1 plus T2, that is nothing but the ratio of speed of the gear D to the gear A. So gear D is nothing but arm D. So speed of the D to A, that is ND by NA, is equal to T1 by T2. So like that. Next, problem number 13. It is appeared in January 2017. A fixed annular gear A and a smaller concentric rotating gear B are connected by a compound gear CD. Now read the first statement very carefully. A fixed annular gear A and a smaller concentric rotating gear B are connected by a compound gear CD. Right, so I should draw two concentric circles. One is for the gear A and it is having internal wheel because it is annular, and another one is gear B. Both gear A and gear B are concentric with each other. Just with a compass or roughly with a point, you draw two concentric circles so that one is bigger one and another one is very smaller one, that you can see in the figure. Next, these two are connected by a compound gear CD. So in between A and B, compound gear CD should come, but compound gear CD is having two wheels, wheel C and wheel D. So therefore now read the next sentence. The gear C mesh with gear A and D with B. See, compound gear CD should be in between A and B as per the first line of the statement. Now gear C, there are two wheels C and D. C should mesh with which gear? Wheel A. Therefore, so C mesh with gear A and D with B. Therefore, draw the compound wheel so that C should mesh with A and D should mesh with B. That you can see now clearly in the figure. The compound gears revolved in a pin on the arm R, which revolves about the axis of A and B. Now, in between B and compound wheel, there should be an arm, so that one end should be connected to the compound gear and another end connected to the B, so that arm R can rotate freely on a pin and about the axis of the A and B. So axis of the A and B is nothing but center of the bigger circle. So number of T's on gears A, B and D are 150, 40 and 100 respectively. So if I list out here, I know after the figure is drawn and after understanding the first three lines of the statement, fixed annular gear A and gear B, which are concentric with each other, connected by a compound gear CD. Gear C of the compound gear is meshing with A and wheel D is meshing with B. After that, so the compound gears revolved in a pin on the arm R, which revolves about the axis of the B, A and B. So there I should connect these two, compound gear CD and the axis of the A and B should be connected with the help of an arm, that he has named it as arm R. So number of T's I listed out. TA is 150, TB is 40 and TD is 100. Now determine the number of teeth on gear C. Therefore I should find TC is equal to what? TC, number of T's on gear C, is equal to what? If the gears A and C have twice the module of the gears B and D. Now look at till now in all our 12 problems, whether in the problem the module is same for all the gears is given or not. By default we have assumed that all the gears are having the same module. Then only the pitch circle diameter or the pitch circle radius of all the gears are directly proportional to the number of teeth. But here he is asking the number of teeth on the gear C, that is TC is equal to how much if the moduli of the gears A and C have twice the moduli of B and D. And next, how many revolutions will B make for one complete revolution of the arm R? So I should find how many revolutions will B make, that is nothing but speed of the wheel B, that is NB is equal to what? If the arm R makes one complete revolution, nothing but the speed of the arm R, that is NR, is equal to 1 RPM. If nothing is given, if the direction of rotation of the any element is not mentioned in the statement, by default it is anti-clockwise, and also it is matching with our convention because we have taken the anti-clockwise as positive. Therefore NR is equal to plus 1 RPM. If NR is equal to plus 1 RPM, then NB is equal to what? Now first let us find the first thing. What is the first thing? Number of T's on the wheel C, that is TC. To find TC, write down from the geometry of the figure. I can write pitch circle diameter of A. Pitch circle diameter of A, that is DA, is equal to DB plus DD plus DC. So if I add pitch circle diameter of B, D, C, that will be equal to DA. And directly you may write now, if the moduli of all the gears is assumed as same, then what I will write, pitch circle diameters are directly proportional to the number of T's. So then TA is equal to TB plus TD plus TC. You write it, TA is equal to TB plus TD plus TC. After writing, now look at the condition. Gears A and C are having twice the module of BD. Therefore, for gear A, I should multiply with 2. Therefore, 2A it becomes. And gear C is also having the module twice. Therefore, TC should be multiplied with 2. Then it becomes 2TC because the moduli of the gears A and C are have twice the moduli of gear B. Now TB and TD, their moduli is 1. That is why I wrote it, DB is directly proportional to TB. But the gears A and C are having twice the module of the B and D. Therefore, I should multiply TA and TC with 2. Then it will fulfill the given condition. So now here TA is known, TB is known, TD is known. Substitute all these values. Only unknown will be TC, that is number of teeth on TC, number of teeth on wheel C. Thereby I will get TC is equal to 80. Right? Remember here this is little different than the previous problems, especially in finding the number of teeth. If moduli is not mentioned in the statement, you have to assume by default moduli is same for all the gears, same. Then pitch circle diameters are directly proportional to the number of teeth. So then TA is equal to TB plus TD plus TC. But here twice the module for the gears A and D. Therefore A and C I should multiply with 2. So then it becomes 2A is equal to 2TA is equal to TB plus TD plus 2TC. If moduli is same, need not to worry. For which gears the moduli is twice or thrice? 2. Twice means 3. 2. And thrice means 3. Like that, how much is the moduli? Accordingly, you have to modify this equation so that you can find this. Next, after finding the number of teeth, to find the speed of the wheel B, now I should be ready with the table. So in the table, first from the figure, you please note down how many elements are there. Gear A, gear B, compound gear CD and arm. Totally 4 elements. Now in the table, first step, second one conditions of motion, third one revolutions of elements. Now whenever in the epicyclic gear train there is an arm, by default arm should be fixed. Therefore arm R is fixed. That is what the first element under revolutions of element. After fixing the arm, now rotate the gear B in anti-clockwise direction. Therefore second comes in the table gear B. And gear B is in mesh with compound wheel CD. Therefore third element is gear CD. And gear CD is in mesh with gear A. Therefore finally gear A. Like that in the order. First, which element I am going to fix? That is first. Next, which element I am going to rotate? That is second. After that, gear B, gear CD is coming in the table. Why? Because gear B is directly in contact with gear CD. So gear CD, after gear CD, gear A I rotate because gear CD is in contact with gear A. Like that in the order. So as and when I rotate, next which element is going to rotate? Like that. So now first table, step number, arm R is fixed and rotate the gear B in anti-clockwise direction by 1 revolution. Therefore write down arm R is fixed and gear B is given plus 1 revolution. So arm R inside the cell I should enter it as 0 because it is fixed. Next, gear B inside this I should write it as plus 1 because gear B I have rotated in anti-clockwise, therefore plus. How many revolutions? 1. Therefore plus 1 I entered. So once the gear B rotated in anti-clockwise, then gear CD will rotate, starts rotating in opposite direction because gear B and compound gear CD are externally meshed. So therefore, gear CD will rotate in opposite direction. But gear CD is a compound gear, so in which gear D is in mesh with gear B. Therefore, TB by TD will give the speed of the compound gear CD, and that is minus because it rotates in clockwise, opposite direction of gear B. Gear B rotating in anti-clockwise. I have rotated in anti-clockwise. On its rotation, gear CD is rotating in opposite, that is clockwise. Therefore, minus TB by TD. So once the gear CD rotates in anti-clockwise, right? So then the gear C, which is meshing internally with A, will also starts rotating. Therefore, gear A rotates once again in the same clockwise direction. So therefore minus. Now how to find the speed of the gear CD with gear A? So TB by TD, that is into then TC by TA. So product of the ratio of reciprocal of their T's of the compound. So then TB by TD into TC by TA and minus because it is clockwise. Next, second step, arm R is fixed and gear B now instead of plus 1 revolution, plus X revolution. You write it, but what I should do? I should multiply all the first row values with X plus X. 0 into X is 0, 1 into X is plus X, minus TB by TD into X is minus X TB by TD. Like that, minus TB TC by TD TA into X. If I multiply, then it will be minus X into TB TC by TD TA. Next, go to the third step. Add plus y revolutions to all. Just simply add plus y, plus y, plus y, plus y, all the elements, to all the elements. Then find the total motion by adding second and third. If I add the second and third of the arm, 0 plus y is y, If I add second and third of the gear B, it is x plus y. Then if I add the gear CD, second and third, then y minus x into TB by TD. If I add second and third of the gear A, it will be y minus x into TB TC by TD TA. Like that, total motion should be calculated. Now you remember in the table only the last row, because last row gives the speed of the different elements. Speed of arm R from the table means you should tell y. Speed of gear B means x plus y. Speed of gear CD is y minus x into TB by TD. Speed of gear A means y minus x into TB TC by TD TA. So like that you must remember. Now go to the statement fixed annular gear A. Therefore gear A is fixed. Hence I can write NA. What is it? Speed of gear A is equal to 0 because it is fixed. But from the table, students, the NA can be also written as y minus x into TB TC by TD TA from the last row of the table. So, and that is equal to 0 because NA is equal to 0. Now, you don't know the values of y and x, that is to be found, but I know the values of TA, TB, TC and TD. So, you substitute. After substituting and simplifying, I will get one equation, that is y minus 0.213x is equal to 0. You call it that as equation number 1. Because in the first sentence only fixed annular gear A is fixed one, it is by default in the according to him. Therefore NA is equal to 0, and from the table I will write down what is NA. I will equate both, then y minus x into TBTC by TDTA is equal to 0. So by substituting known values I will get equation number 1. Similarly, to find the speed of the wheel B in the given thing, he has told I should find the speed of wheel B if the arm R makes one complete revolution, means NB is equal to what? If NR is equal to 1 RPM. So, speed of the arm, that is NR is equal to 1 RPM, but from the table the speed of the arm is equal to, from the last row, it is y. So therefore y is equal to 1 RPM. Directly I got the value of y, that is equal to 1. Now substitute this y is equal to 1 in equation 1. Then in doing so, y minus 0.213x is equal to 0. Y, just now I told it is 1. So 1 minus this, and if I substitute, I will get the another unknown value, that is value of x. So it is approximately 4.7. So x is equal to 4.7, y is equal to 1. After knowing x and y value, what I should calculate, students, here? I should calculate the speed of the gear B. So therefore speed of the gear B, that is NB, from the table, that is equal to x plus y. So now I know x value and y value, both substitute, then it will be 5.7 RPM. So as the value itself indicates that it is plus 5.7 RPM, therefore NB is equal to 5.75 RPM is the speed, and rotation means in the bracket you write down anti-clockwise because it is plus. According to our sign convention, it is anti-clockwise because positive is anti-clockwise and clockwise is negative. Like that, these are the 3 problems, question paper problems in addition to the 10. Now the last content in the gear trains is, because still now in gear trains what we have discussed right from the definition of what is gear train, types of classification of gear trains, simple gear train, compound gear train, epicyclic gear train and reverted gear train. After that, especially on epicyclic gear train, we have solved some 13 problems, including the question paper problems. Now, the one more thing, because in the in all the 13 problems, what we have done, just using a velocity ratio formula, we have calculated the speed of the different elements that are present in the given type of gear train. So now, in addition to the speed, we can also calculate the torque. Therefore, now briefly in 5 minutes, let us understand how to find the torque in case of especially epicyclic gear train, because you can calculate velocity ratio. Now you can calculate the number of T's, you can calculate the speed of any element in the given gear train, and you know that gear trains are being mainly used whenever the power is to be transmitted from one shaft to the another shaft. So whenever there is a power transmission, definitely there is a torque. Therefore, in addition to number of T's on the wheel or gear, whichever is unknown, and speed of any gear or wheel in any given gear train, and velocity ratio. So number of T's, speed, velocity ratio. In addition to that, you can also calculate the torque. So how to find the torques in epicyclic gear train? Because now, as I said just now, when a power is transmitted from a geared system, the torques are transmitted from one gear to the another gear. Because mainly, you know that, so the gear trains are made or preferred in order to transmit the power from one shaft to the another shaft. So whenever you does the power transmission with the help of gears, the torques are going to transmit from one gear to the another gear. If all the gears of a gear train rotate at uniform speed, that is, angular acceleration of gears is 0, angular acceleration, that is alpha, is equal to 0 notation, then algebraic sum of the externally applied torque must be 0. That is, mathematically, sum of T is equal to 0. Now, if you look at the figure, as shown in the figure, the gear train is kept in equilibrium by the 3 externally applied torque. Now, I have drawn the 2 figures. One is having input and output shaft, both are being connected by one fixed member, and second one is also same. But the first one, A, input and output shafts rotating in same direction. Now look at, input shaft is rotating with an angular speed of omega 1, and output shaft is also rotating in the same direction with the same speed, angular speed omega 2. So omega 1 and omega 2 are the angular speeds of the input shaft and output shaft, and both are in the same direction. And in the second figure, the input shaft speed and output shaft speed are rotating in opposite direction. That is why in the diagram you can see omega 1, omega 2. What are omega 1 and omega 2? Angular speeds of input and output shaft. Both are in opposite direction. So like that, I have considered the 2 cases of the input and output shaft which are connected by the fixed members. Now in the figure, either A or B, any figure, either figure A or figure B can be kept in equilibrium by the 3 externally applied torque. One is input torque on the driving member, that is nothing but input shaft. So that is T1, and the second one is output or the resisting torque on the driven member, that is T2. So what is T1? Input torque. That is the torque which is acting or applied on the input shaft, and T2 is the torque which is going to resist, resisted by the driven member. So input shaft is T1, output shaft is T2, and in between there is, these 2 shafts are connected by a fixed member. Definitely some amount of torque will be acting in the or developing in the fixed member. Therefore that is called braking or holding or fixing torque on the fixed member, that is T3. So T1 is the torque on the input shaft, T2 that is the torque on the output shaft, T3 that is the torque that is going to develop in the fixed member. So in both the figures there are fixed members. There is a fixed member. So with the help of fixed member, so the two shafts in between which the power I am going to transmit. So to keep the gear train, given gear train in equilibrium, especially here there are three elements. One is input shaft, second one is output shaft, and third one is a fixed member. So these three on which the torques should acting are T1, T2 and T3. Now as I said, the net torque on the gear train must be 0. Then only we can say that it is in equilibrium. Therefore, summation of all the torques is equal to 0. Now what are the torques that are acting on the three members in the given gear train? Input shaft T1, output shaft T2 and torque on fixed member is T3. Therefore T1 plus T2 plus T3 should be equal to 0. That you call it as 1. But torque, basically what is meant by a torque? It is whenever a force is being applied with a certain radius. So then that is called as a torque. So therefore torque is equal to force into radius. Therefore T1 is nothing but F1 into R1. What is F? Force, and R means radius. So F1 R1 plus T2 F2 R2 plus T3 is equal to F3 R3 is equal to 0. So where F1, F2 and F3 are the externally applied forces at radius or radii are R1, R2 and R3. If I take omega 1, omega 2 and omega 3 are the angular speeds of the driven and fixed member, then the kinetic energy dissipated by the gear train by neglecting friction must be 0. That is, for rotational members, for translational members, so the kinetic energy is equal to half mv square. If I write, if any element is a rotational member and the kinetic energy is torque into angular speed. So therefore, T1 into omega 1, this is the kinetic energy in a input shaft. T2 into omega 2, this is the kinetic energy dissipated by the driven shaft. T3 omega 3 is the kinetic energy dissipated by the fixed member. So T1 omega 1 is the kinetic energy of input shaft, T2 omega 2 is the kinetic energy of the output shaft, T3 omega 3 is the kinetic energy of the fixed member. Sum of all these three kinetic energies is equal to 0. So provided if the friction in between each and every member is neglected. So by neglecting the friction in between each and every member which are connected in the given gear train, then the kinetic energy dissipated, sum of the kinetic energy dissipated by all the members is equal to 0. So T1 omega 1 plus T2 omega 2 plus T3 omega 3 is equal to 0. But as I said, in our figure A or figure B, the two shafts which are connected by the member is a fixed member. So therefore, what is the speed of the fixed member? Omega 3. So hence omega 3 is equal to 0. Thereby if I substitute, then I am going to remain with T1 omega 1 plus T2 omega 2 because omega 3 is 0. Why omega 3 is 0? So because omega 3 is the angular speed of the fixed member. In the name itself, fixed member. Therefore, omega 3 is 0. Then T1 omega 1 plus T2 omega 2 is equal to 0. Then, so T2 omega 2, I can write it as taking this term on the right hand side minus T1 omega. From this, T2 is equal to minus of omega by omega 2 into T1. And also, from in the equation 1, I can write T3 is equal to minus of T2, T1 plus T3. So T3 is equal to minus of T1 plus T2. Just now I found by equating the sum of the kinetic energies, that is minus omega 1 by omega 2 into T1. Now it is minus of T1, plus into minus is minus omega 1 by omega 2 into T1. Then So if I just take it T1 outside, then minus already it is there. T1 I am bringing out, so minus T1. Then I will be left with here inside the bracket 1 minus omega 1 by omega 2. So if I bring minus also outside, then it will be plus T1, and this minus omega by omega 2 will become plus omega 2 by omega 1. This plus 1 I am bringing minus outside, therefore it will become minus 1. So therefore T3 is equal to T1 into omega 1 by omega 2 minus 1. T2 is equal to minus of omega 1 by omega 2 into T1, and equation 1, sum of all the torques T1 plus T2 plus T3 is equal to 0. This is only one more note here. You can see from the figures 2 points which we can write. If input and output shafts rotate in the same direction, then T1 and T2 will be in opposite direction. That is what you can see in figure number A. Similarly, if input and output shafts rotate in opposite direction, then T1 and T2 will be in the same direction. That is what T1 and T2 will be in the same direction. So whenever the two shafts are rotating in same direction, the torques will be in opposite direction. See, T1 will be in clockwise, T2 is in opposite. So opposite. Then when two shafts are rotating in the opposite direction, because your omega and omega 2 are opposite, in such case T1 and T2 will be in the same direction. So like that, this is about an torque, how to calculate the torque in epicyclic gear train. So need not to worry, but now I will take up another 3 to 4 problems on gear train, especially on epicyclic gear train, in addition to the speed and number of teeths which we have calculated. In the next class, how to find the torque also will be dealt in the problems. So you need not to worry about the torque theory, only just for the explanation purpose I have told. So, but how to calculate the torque, that I will explain by taking up the examples in the next class. Thank you, one and all.